Hi, we're going to take a look at grading an FRQ from the 2018 AP test. Problem number 4 about the ACL and stabilizing the knee and all that good stuff. Let's take a look at the rubric for grading it. So for the first part right here, it says based on the design of the study, would you be able to, would a statistically significant result allow the medical center to conclude that the new procedure causes a reduction in recovery time? The word causes is the main word right there, and so you have to know when in the AP stats you're allowed to actually address the causation issue. Okay, correlation isn't enough, but if it is a well-designed randomized experiment, it will be able to be you can assess a causation kind of component to it. So the answer here is yes, it would be reasonable. Okay, so there needs to be an affirmative answer for this particular problem. Okay, you don't have to say the word yes. You can say, yeah, it would be reasonable to. Okay, so make sure you have sort of an affirmative, positive kind of answer. The reason why you can do that is because in an experiment, you can show cause effect. So in this case, they address that, yes, this is an experiment, so you can have causation. Okay, and the last thing that we're looking for is, do we have context? I see the word patients, treatments, all that good stuff right here. Throw in ACL. They do have context right here, so my person gets 3 out of 3 for this particular problem. Now for part B, they tell you summary statistics on the recovery times for those patients that had the standard surgery versus the new procedure, and you can see that they give you sample sizes, mean and standard deviation. We know that we have 2 groups, and so immediately when we have means and standard deviations about 2 groups, you know this is going to be a 2-sample t-test or interval depending on the question. But because it talks about is there convincing statistical evidence, you know it's going to be a test. So we know that before we even think too much, we know it's going to be 2-sample t. Okay? Now, the first thing that I'm going to be looking for is the first check mark is for the ho, and the next check mark is going to be for the ha. Okay? So, in this particular case, the difference is equal to 0. Okay? And ha is the difference is, all right, you can see here that they use 1s and 2s here. I'm going to change this to surgery, okay, or standard, and N for new, S for standard, N for new, okay. So if that's the order that you did them, give yourself a check for the ho and a check for the ha, okay. So if you reverse these two, it would be a less than sign, but I bet most people did it this way, okay. So the first 2 checks have to be with the ho and the ha, okay. The next thing I'm looking for, which might have to be, they gave you plenty of room to write on this particular question, is I'm looking for the conditions going on right here, all right? Now this person right here, when they did their conditions, all right, they have random. What I'm looking for is 9 conditions to be checked, okay? And I don't see enough here to show 9. I also don't see the independent groups assumption, that the people in the one group that has the new treatment versus the standard treatment are independent of each other. I am not going to give them the credit for checking all the conditions for this particular problem. All right. The next thing that we're looking for is their since statement. Do we have the name of the test that they were using in this particular problem? All right. So I'm looking around. Okay, I'm going back to the front page right here. I don't see it. All right, I don't see the name of the test at all, okay? So I am not going to give them credit. It needs to be a 2-sample t test since all the conditions are met, okay? That's really important, okay? Because without naming the test, you have to use your complete formulas. You have to build your normal models. You have to show all your work with the z-scores and t-scores and whatever scores that you're using to be able to get credit for this particular problem. Okay, if you identify the name of the test, you can do a direct copy off your calculator as soon as you've run the test. Okay, so the next one, p-value. The p-value is about 0. Check. The t-statistic, okay, you get that off your calculator too. is 7.127 or 7.13, something like that. Check. The degrees of freedom, I'm looking for the degrees of freedom. It is not that, all right? Okay. For a 2-sample t-test, you get it off the calculator, and the answer is 207.18. So my person does not get credit for that particular part of the problem. Okay. So in the mechanics, a check for the t, a check for the p-value, and a check for degrees of freedom. There's other stuff that you'll have written down off of your calculator, but I'm not going to give check marks for that. All right. So now what we're going to move to is the conclusion. All right. So we're looking for, first of all, I need to compare my p-value of 0 to the alpha level of 0.05. This person says it's less than, so I'm looking for that linkage part of this particular question. All right. Then the conclusion you draw, I'm going to reject the hoe, check. And then the last check right here is going to be, I have evidence of, and then in the words of the question, you're going to write down exactly what the question is. I have evidence that the new procedure will have less recovery time from the surgery on average than those who receive the standard procedure. Okay, and they have that check, all right? And so I have evidence of that. Okay, so for the part B, all right, there are actually 10 different checks here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 9, 10. All right. My person is missing 1, 2, 3 of them. My person got 7 out of 10. Okay, so the final overall total is 13 points. My person got 10 out of the 13. I'm going to box it. Okay, and that is the end of grading this particular question. Bye.